Now we are going to start talking about incorporating lampreys into in-water work projects. So we talked about threats that exist on the landscape, and so I'm going to kind of go through all those threats, how they are similar or different from the threats that we know a lot about when it comes to our native salmonids. So initially, especially for passage, a lot of times we are going out and assessing barriers to try to figure out whether or not this is a barrier that is blocking passage or not. And in the context of Washington State, we are oftentimes looking at whether or not a 6-inch trout or a Chinook salmon can navigate those barriers for different reasons. However, lamprey, a barrier to lamprey is not necessarily a barrier to salmonids and vice versa. Salmonids are great jumpers, even that 6-inch trout is at a decent jump, but Pacific lamprey are not good jumpers. So even a small perch or a culvert can be a complete barrier to these fish. Pacific lamprey are great climbers. So there's a couple examples of some pretty epic climbs that Pacific lamprey can make. So Willamette Falls there is on the lower left. The falls itself is almost 40 feet tall, and then there is actually a dam on top of the falls, and then dam boards that get added in the summer on top of that. So this is a permanent structure. This is additional dam boards. So they are scaling over 50 feet to get over that falls. These are basalt columnar basalt falls, and so they're climbing that and getting over that, just incredible. And then the black and white photo there is from a falls in California. That's a granite falls, and lamprey were historically the highest source of marine drive nutrients in this watershed. So steelhead couldn't jump this fall, but lamprey could climb it. And they actually did blast a fishway into this falls, I think in the 40s or 50s, so that salmonids could get in there. But historically, only Pacific lamprey could navigate that falls. And so our other native lampreys, we don't think have the same epic climbing ability. Pacific lamprey, and then there's another lamprey in New Zealand, the pouch lamprey, are kind of the famous climbers in the lamprey world. But when we're thinking about Pacific lampreys specifically, this can be really important when we're thinking about natural falls. So is there a natural fish above a natural fall? There could be, but we're not thinking about lamprey. And then for prioritization and restoration projects, an artificial barrier, is it that perch type? And if it's a very small perch, it can be a complete barrier for these naturalist fish. However, if there is the ability to climb something, they can then navigate it. So we looking at assessing barriers through that lamprey lens is really important. So as far as swimming capabilities or the way that lamprey move, as I mentioned, they're anguilliform swimmers. So they are not as powerful, but they are very efficient. So their sustained swimming speed is about 3 feet per second, so it's much lower than our salmonids. And the real difference is they just don't have that burst speed that salmonids have. So when they're entering in a fishway, going up and fall like a jump, they have a really strong burst speed, and lamprey don't match that at all. When they navigate swift waters, they use a burst attach motion. So they're actually holding on with their mouth and they're bursting forward and then reattaching. And so they require smooth attachment surfaces. So you can think of that basalt column or the granitic rock, that they're actually attaching to that. And so that's what they are needing, smooth surfaces in order to navigate challenging barriers. And of course, lamprey can climb these vertical surfaces, but it requires that smooth attachment. And our other smaller body lampreys may not be able to navigate even at these speeds because they're smaller, weaker swimmers. So Pacific lamprey are kind of our best swimmers. And then our other lamprey are less powerful. So here is a video showing some lamprey climbing. So they're also using that burst attach motion to climb vertically. So they'll attach and then they'll let go and basically kind of wind up their bodies and jump up and reattach. And this is a dam that's actually a pretty challenging climb because you can see there's lots of chunks in the cement. You can see like the layers, so a lot of lamprey are falling back. They're all in here. This is actually a really big return in this river But this is pretty challenging, these chunks. A little bit of a smooth corner, but just kind of, the cement is kind of worn out. But it's pretty amazing. They're just climbing this vertical surface, no problem. And then here is another video showing, so this is in a fishway. And so the Pacific lamprey here is trying to navigate these really fast velocities that are at the entryway for the fishway. So it's got a lot of its body out of the water because it's trying not to get hit by those fast velocities, but it gets knocked off. Oh, tragedy. It's trying again. Actually, I think it's slow motion, but it'll try again. Just getting knocked back, and then it comes back in the eddy, tries again. Oh, so sad. So then it finally makes it around, and no, there's a slot for dam boards or weirs, and it cannot navigate that. It's very bad. So this is something where we would not even think about those issues when it comes to salmon and catfish. We wouldn't think about the smooth edges. We wouldn't think about these slots. We wouldn't think about corners at all. No problem for salmonids, and that can be completely detrimental to the lamprey and extremely costly when it comes to energy. So they're having to reattempt this many, many times in order to just try to navigate these barriers. So when it comes to identifying and assessing barriers, any surface drop can be a complete barrier for Pacific lamprey and our other native lampreys. So even that, a quarter of a meter for our 6-inch trout would be too much for a lamprey. Slope, they can, climb these 90-degree surfaces. So slope is not as much of a deal, but if it is in a, for example, culvert, oftentimes that higher slope is going to result in higher velocity. So those velocities are going to be a barrier. When we're designing our culverts, even at the kind of low end for our shorter culverts, that 4 feet per second is right at the edge, if not above the swimming capacity for a lot of our Pacific lamprey, definitely our smaller bodied lamprey. They're going to really struggle to get through those structures. A couple things to think about that are beneficial are having rest locations within the culverts themselves, and making sure that there's attachment surfaces so they can use that first attach motion through those barriers. Depth is something that we consider, especially for our larger bodied Chinook salmon. So when we're thinking about passage, we are looking at those depths to make sure they can navigate through. That's probably not as much of an issue for a lamprey. They can navigate when it's really just a thin sheet of water. And so that's something that's a benefit to lamprey. There might be some cases where they can get through a structure that potentially a Chinook salmon can't. But likely, all of these things added up, there's way more barriers on the landscape for our native lampreys than when compared to our native salmonids. So when I'm talking about attachment surfaces, we're thinking, what can they actually suction onto? And so in nature, they're again climbing these bedrock falls. They'll hold on to rocks and they'll jump kind of from rock to rock in these fast velocities. So that's kind of the natural version, but conglomerates, which oftentimes when we have kind of worn out eroded concrete, these can be really challenging. They just can't get that suction on there because there's all these chunks. And so oftentimes with our infrastructure, that can be a component that's just old and worn out and potentially completely blocking lamprey if they can't hold on. 90-degree corners, that can even be, if there's relatively high velocity in a culvert and the wing walls have 90-degree corners, that can prevent them from getting in right at the entryway. Those corners just are really hard for them to navigate. So we recommend that they are actually rounded. So this is happening more and more in fishways specifically, but can also be incorporated into, culverts, larger box culverts and whatnot. This is more, again, for fishways, it's diffuser grading. So a lot of times there's grading to move water into areas where encourage fish to be there. That can be a complete blockage for lampreys as they're navigating, because again, they want to be holding on. Excessive algae or biofilm buildup, that can prevent lamprey from being able to get in. So that's kind of more of a maintenance thing. And then thinking about culverts are corrugated metal pipes. that are oftentimes, in our older structures. Those can be challenging, especially if they're eroded and chunky and, in the process of failing in many cases. We can still have water flowing through those areas. Oftentimes it's pretty high velocity, but there's nothing for lamprey to hold on to because it's been eroded and corroded. So thinking about passage, restoring connectivity, removing a barrier is obviously one of the best things that we're doing more and more on the landscape for all of our native fish, and providing these natural flows through historically blocked areas. That is very beneficial for, everything involved. However, that's not the reality in most cases, but we are moving more and more towards stream simulation. So I'm sure a lot of the projects you all are working on is, that stream simulation model where we're actually mimicking the stream through the barrier, restoring processes so water, sediment, organics, and creatures can move back and forth. But just to highlight a couple things that are particularly important for lampreys, would be the low flow channel. So that year-round low flow channel, because in certain areas, lamprey are moving and migrating in the summertime. And so making sure that channel is distinct and has water and they can navigate those barriers is really important. The other component that can be really important is oversized structures within the passage, within the culvert, so that they can attach those and rest. Because again, they're going to be essentially at kind of the edge of their ability to sustain swimming speeds through those passage structures. And so having oversized material where they can hold on and rest and have kind of some eddies where there's slower velocities can be really beneficial. So it doesn't have to be a giant boulder all the time, but just having something that's creating that flow path diversity that they can tuck in and hold. And again, our Pacific lamprey are our strongest swimmers. They are going to be able to navigate these the best, but all those kind of features of the low flow channel, the oversized structures will also help our other native lampreys, our Western Brook and Western River lampreys, as well as just our other smaller bodied fish. And when, again, kind of thinking about the structures themselves, velocity and the actual entry into the culvert is going to be really important. So in assessing a potential barrier, if that entryway has got especially high velocity, that can be a challenge. The surface material through that culvert, and then the length of the crossing, it can be hard, especially at those higher velocities. And this may be, this is kind of on the lamprey retrofits end of things. And these can be used in fishways, which sometimes we have put, fishways, weirs, baffles into some of our passage structures to facilitate a greater percentage of salmonids being able to pass those. But those can actually block lamprey as well. And so especially if they are not easily scaled because of the surface material or because they've got uneven corners, they're funneling water and can become fast. And so some of these retrofits can be used for that. A lot of this is a little bit targeted towards oftentimes our fishways that are big and structural are in hatchery situations. And in that case, we're recommending these rounding corners so that lamprey can climb over the weirs. You can also add orifices into the bottom because lamprey tend to navigate along the bottom and they kind of tend to navigate on the sides. So you can add these orifices that allow them to navigate there and not have to go over or around in the highest velocity sections of the weirs. This here is an example of a pretty, this is a very simple lamprey passage structure. This is at Willamette Falls. There was an old fishway and they noted that lamprey were kind of kegging up and trying to navigate it. And so they added this wetted wall, which is just aluminum, and the lamprey just climbed right up it. So this is like a simplified version of a lamprey passage structure. We now kind of recommend making them covered because there could be a lot of avian predation from these if they're exposed. But they can be really easy to add to structures and facilitate a lot of lamprey passage. But again, specifically Pacific lamprey because there are super awesome climbers. So one of our other threats is related to flow management and dewatering. And so this is most commonly kind of in our issues with screening. We say fish screen, but we really mean salmonid screening. The screening criteria is set to protect our ESA listed salmonids for very good reason, obviously, but they are not necessarily going to protect all of our smaller bodied fish. So this can be important at our project sites where we've got pumps that are dewatering our project areas. It also, is at a number of everywhere on the landscape where we've got diversions for water, that those screens oftentimes are not protecting all age cohorts of lamprey. And so we can have some pretty big impacts from this. This is an area of kind of continued research. We've got a white paper that summarizes the effects of entrainment and impingement on the Pacific Lamprey Conservation Initiative's website. And so we will be sending out a lot of materials and reference documents, but this can be the kind of screening piece is an ever kind of evolving interest for the Pacific Lamprey Conservation Initiative, just because there's so many screens on the landscape. And we kind of take them for granted, but they are not necessarily protecting lamprey. So there's some pretty large examples of NIMS criteria screens that a ton of larval lamprey end up behind, even though, we call them fish screens. So potentially using smaller screen openings, which requires a larger surface area in many cases, but for some of our pump screens, we can use in project sites, just making sure they're at the very minimum NIMS criteria, NIMS compliance, the 3/32 inch opening, or potentially smaller to protect our smaller body lampreys. So this is an example of actually the lamprey behind a fish screen. So this is the accommodation for a dredging project. So I always talk about dredging, and it really varies on the audience. Some people work on dredging projects a lot. Some people just never do that. So I will kind of go over this quickly, but if you have questions specifically about dredging, we can talk much more about it. But the dredging occurs, for restoration projects, just to remove sediment, to make room for our new passage structures. Potentially, it also happens a lot with agricultural environments. So agricultural channels and ditches to remove sediment that build up. And that can be some really awesome lamprey habitat. So dredging projects can have a very high density of lampreys in them. And this is where that information regarding the depth of which lamprey are at, it can be really useful. So we know they're in that top 9 inches, 23 centimeters. We think they're probably deeper. And so we recommend for dredging projects to remove the top 30 centimeters or 12 inches of a project and look for lamprey in there. And so that can be, for example, in the picture there with the accommodation, where you're actually removing that sediment and then dispersing it on the side of the project and then going through and actively removing lamprey. A lot of folks do that for agricultural ditches. It can just be easier than actually getting in there and trying to salvage lamprey, because sometimes it's, it's hard to block in those areas and it's a large area. So this can be actually relatively efficient at getting lamprey out. For our deeper projects, dredging projects that are more for like navigational channels or around, boat areas, boat launches, harbors, we do a lot of dredging there. And those can be we don't really have methods for getting lamprey out of those areas. But that is something that we are also working on, just trying to understand how lamprey use those deep water environments. They are found in up to 50 feet, 15 meters or higher depth in the Columbia River. So they're in our large scale rivers and utilizing those habitats. So they're very challenging to work in and remove lamprey from. This is, as I said, a kind of ever evolving topic for the Pacific Lamprey Conservation Initiative. And we have some summary documents there as well, links there for dredging. So if you've got projects that you're working on, feel free to reach out. And then also there's a group of folks working on this and trying to learn more. So habitat, stream and floodplain degradation is also one of the threats that has impacted our native lampreys and obviously impacted our native salmonids as well. And we think there's probably a lot of overlapping benefits in all the restoration work that we are conducting in the name of our ESA listed salmon. And that is probably benefiting our non-ESA listed Pacific lamprey and native lampreys. We don't have the science and trying to understand what restoration is in its early stages, even for salmonids. And we do not have very much science when it comes to understanding the impact of restoration on lampreys. So in lieu of that data, what we think is really beneficial is restoring watershed processes. So recreating the processes that support diverse habitats and those multiple life histories that require a lot of different habitats within the stream environment. And then also the connectivity between those environments. So increasing channel complexity, adding structure, large wood, boulders, that we think is really important for our native lampreys. That creates adult holding and predator refugia. It increases sediment sorting, so we get those pockets of fine sediments as well as pockets of good spawning habitat. And we just get these also flow path diversity, so low velocity areas, high velocity areas. So structure, we think, is a really important component. Obviously, what we've lost in many of our rivers and are doing a lot of work to restore. Also projects that increase lateral and vertical connectivity. So increasing that wetted area and that hyper exchange is likely very important for our larval lamprey because they are living in extreme environments for years at a time. So that year-round wetted fine sediment is extremely crucial. And then just removing those channel confining structures. So we've got a lot of levee setback projects, a lot of projects that are trying to really restore the floodplain connectivity, and that is likely very beneficial for our lampreys in addition to our salmonids.
Knowledge check. Multiple choice. Stream and floodplain degradation has been identified as a threat to both salmon and native lamprey. Which habitat restoration project elements are likely beneficial to both salmon and lamprey? 1. Design diverse habitats that support multiple life stages, including gravels and cobbled for reds, and cool soft bottom pools for rearing. Or 2. Add structure to channels with engaged large woody debris and undercut banks for holding and predator refuge, flow path diversity, and increased sediment sorting. Or 3. Increase lateral and vertical connectivity by removing channel confining structures and increasing hyportic exchange. If you chose 1, 2, and 3, you are correct.
For water quality, I think there's a lot of benefits, overlapping benefits to what we've been doing in the name of salmon and steelhead. And so the one thing being that lamprey has a much longer freshwater residency time. So probably the things that are impacting our salmonids are even more so impacting our native lampreys because they're just using that freshwater environment for so long. So lampreys also need clean, cold water. The larval lampreys probably have a little higher temperature tolerance than our salmonids. They can withstand some higher temperatures in their larval stage, and there's some evidence coming out of Eastern Oregon suggesting that they can be in some pretty hot water and still be alive, which is pretty cool. We don't know kind of the long-term impact on kind of their growth and whatnot, but they are surviving in pretty warm temperatures, which I think it was like 28 degrees C. However, for the adult life stage, we have seen in the last few years some pre-spawn mortality due to high water temperatures. So we'll likely see more of that as summer temperatures get elevated, but during that time, we've got lamprey holding in the stream, adult lamprey holding in the stream, and there have been a number of incidences where that has been, we are seeing lamprey pre-spawn mortalities. The other thing is just, again, that long residency time for the larvae. They're in this freshwater environment for over 10 years, and they are bioaccumulating toxins. There's been a couple papers out of USGS looking at accumulations of a number of different chemicals, and they are accumulating those at the larval stage. We don't know kind of the impacts of mortality, maturation, growth, but that is something that we need more information, especially in some of these more urbanized and heavily agricultural environments, that potentially is impacting these populations as well. But what we're doing is to help on the salmon front, it's probably great for lamprey. So, you know, just riparian plantings and fencing, making sure that riparian area is really strong and has lots of, you know, cover and shade and, you know, bank stabilization, all those impacts very beneficial for lamprey. In areas, especially with low summer flows, purchasing water rights, using water really efficiently will be important. And then more in our urbanized environments, that stormwater treatment, incorporating that into our projects is likely very beneficial. Predation is another thing that I won't go into too much, but likely a lot of the kind of exacerbated predation on our native lampreys is due to passage impediments. Because lamprey on the upstream end are reaching barriers they cannot navigate, and they are trying to figure it out, and they are just easy picking for native predators. So otters, mink, they just like will sit below some of these structures. We see this at hatcheries oftentimes where lampreys can't get into the fishway, but they're trying to still navigate the barrier dam, and they are just being munched on by the native predators. So that is, we would expect those predators to eat them to some degree, but these barriers are causing these particularly high mortality locations that are completely unnatural in the landscape. It also leads to a lot of energetic losses because they're going back and forth trying to figure out how to scale these barriers, and then also potentially time loss. So they might be missing crucial environmental windows for spawning because they can't actually get above a barrier. So that is kind of a issue with just the fact that there's so many barriers on the landscape that are impacting lampreys, and just kind of an added cumulative effect to that that issue. There's also, you know, more and more non-native predators that we're documenting in our watersheds, and those are have been shown to feed on our native lampreys. So that could potentially become continued problem, especially with warming stream temperatures. So specifically for projects and thinking about lampreys, starting at the pre-project assessment level, one of the just kind of easiest things to do is, do we have lamprey present at site? And I say that, but it's actually weirdly hard because we don't have a lot of data. So we have a new distribution map that has a lot more data for Washington State than historically we have had in the past. But likely the data that is on here is still a percentage of what where lamprey are in the landscape. So this is a distribution map. It uses both eDNA and then kind of like hands-on observation of lamprey. And I am guessing that there are many more streams across the region, across the state where we have lamprey that are just not documented on here. So it's a good place to start, but I also recommend thinking about whether or not you're designing a project for other anadromous salmonids, coho, steelhead, and if you are, there's a really high likelihood that historically, at the very least, there would have been Pacific lamprey present there. It is possible that there's a downstream barrier that is preventing them from getting there, but in general, if you're designing a project for salmonids, I would guess that very likely there would be Pacific lamprey at that site as well. For our resident lamprey, we don't have a distribution map for them. There is some Lampetra data on this map, but it has not been, it's very patchy and we don't collect it as consistently. So, and we just don't have, for example, the spawner survey data because we're not out there looking for the small reds typically. So, so for the native resident lamprey, they're even more widely distributed because again, they're in those smaller tributaries, but we just don't have that information. But again, using our native trout as a surrogate, if you're thinking about trout at your project, it is very possible you've got resident lamprey as well there. And then the other, just, you know, thinking about your pre-project, you're going out to a site, thinking about incorporating lamprey into the designs and the salvage. And it's also, I think, very beneficial to just think about whether or not you have lamprey habitat there. So I was working here in the Skagit, we were doing a pre-project lamprey survey, because it was our lamprey present at this project, and it was this like chock full of larval lampreys, so many larval lamprey, and that can really help inform the fact of okay, we're gonna design this project, there might actually be some really beneficial habitat here we want to maintain. But while still adding to the benefit for other species in that location. Or during salvage, we want to make sure we're really targeting these areas that have high density larval lamprey because we know they're here and they're utilizing this habitat, even if we're going to do a project there. It's also helpful to kind of think about whether or not adults are spawning in the region because that can potentially impact your time frame of in-water work. And so looking for those course materials, knowing that if there's steelhead spawning there, there might also be civet lamprey spawning there. On the in-water work note, our in-water work windows have been designed to reduce impacts to our salmonids. Obviously, for very good reasons, right? We've got these ESA listed fish. We do not want to impact the really important parts of their life stage, spawning, juveniles migrating out, smolts migrating out. We want to reduce our impacts. Also, the summertime is when we have the lowest flows, so it's also easier to get in and do our in-water work and minimize impacts. However, when it comes to lamprey, this in-water work window is not avoiding their really important life stages. So adults will spawn into August, but many places they're in June and into July. And so those earlier portions of our in-water work window are going to be overlapping with adult spawning, adults folding, and eggs in the gravel. So that is a very crucial life stage that potentially is impacted. In the later parts of our in-water work window, we'll have transforming juveniles. So again, that's similar to our smolt life stage for our salmonids. Really important. They are not feeding during this time. They're making a huge change physically. They're metamorphosizing into that juvenile, really energy intensive. And so protecting that life stage is also really important. And then no matter when you work in water, you're going to have tons of larval lamprey, multiple age cohorts. So even though we are trying to avoid impacts to salmonids, we're not avoiding those impacts when it comes to lamprey. And so thinking about that, depending on your project, is there a way to avoid excavation or dewatering of particularly high density areas? If there's spawning occurring at your site, is it possible to shift your project to a later time frame so that you can allow those lamprey to mature? They're in the red for about a month usually, so it's not a super long incubation time. But depending on the scale of the project, that might be possible to avoid. But if it's a smaller project that shouldn't take very much time, moving that towards the later part of the in-water work window could be beneficial for your native lampreys.
Knowledge check. Multiple choice. In-water work windows are designed to minimize impact to salmonoids, not lamprey. Which of these statements are true about the fish window and lamprey? 1. During the early part of the in-water work window, fish rescue teams may encounter adult lampreys, who spawn from June to early August. 2. During the later part of the in-water work window, fish rescue crews may encounter transforming juveniles who are going through a process similar to salmonoid smoltification. 3. Larval lamprey live in freshwater environments for up to 10 or more years. Dewatering quality rearing habitat without proper salvage can kill many cohorts of lamprey. And 4. Eggs spend all summer, about 3 months, in the reds before they hatch into larvae. Answer 4 is not true, because lamprey eggs develop into larval lamprey in about 1 month. Answers 1, 2, and 3 are all true.
But avoiding those impacts is not always possible, right? We have to do our in-water work. We got to get in there. We got to do the restoration and passage work. So what we suggest is having a lamprey salvage plan. So kind of extra steps to the typical salvage work that we do that will hopefully protect a few more lamprey in these situations. So one of the kind of easiest thing is just having fine mesh nets when you're doing your fish salvage. A lot of the nets that we typically have on site have mesh that allow many age classes, potentially all larvae and juveniles, to slip through the mesh. And so we can, even if we are seeing them, we might not be catching them. Having an extra bucket and aerator on site and leaving it on site is highly recommended because lamprey don't always come up right away. So even when we finish salvage, you might have a lot of lamprey that are still at the site. And if you leave that bucket and aerator on site and someone is there to be able to scoop them up, that can be beneficial because we oftentimes see them after our initial salvage is completed. And then all of these things, just thinking about that extra time that it might take and extra people that you may need in order to conduct that salvage. And this is super variable depending on the scale of the project, because sometimes we have a relatively small footprint and it's a kind of confined area that we don't have to take a lot of extra time. It will be a pretty quick process to get lamprey out. And other times it's a massive restoration project and it is spanning a large area and it can take a lot more time. So but planning ahead will hopefully alleviate stress at the time of salvage, and then also won't waste money and time because you are prepared for the situation that is at that location. We also recommend slower drawdown rates. So 1 to 2 inches per hour. This allows lamprey to self-salvage. So they'll basically come out when the water is removed and then follow the water. So you'll get them in kind of a concentrated area. This can be particularly useful where you have a relatively confined channel and there's steep-ish slopes. When you have a really shallow slope, that 1 to 2 inches dewaters a larger area. And lamprey can't always keep up with the edge of the water at that point because they're not able to move along the surface, especially smaller larvae. So this, depending on your location, even as you're drawing down, it's helpful to have people there that have buckets and can scoop up lamprey that can't quite keep up with the water. But in theory, where it is useful is you then have this kind of concentrated area that you have to defish, and you don't have to spend as much time in a larger area. Emergence time is really variable. There is a paper that just came out in last year that summarizes a lot of the studies that have been done to evaluate dewatering and emergence. And generally speaking, most lamprey are going to emerge in the first 30 minutes, but this really does vary based on the conditions of the site. They can stay in that stream bed, in that hyper zone, and have water and feel safe. They may not want to emerge as readily. So it really varies on the environmental conditions. Lamprey have been shown to survive at least 22 days post surface water being removed from the site. So again, it can vary greatly on when lamprey are inclined to come out. And some of those impacts are, again, that sediment type and whether or not it's holding water, components to whether or not lamprey are surviving our dewatering, and kind of how we can plan our dewatering. As I mentioned, slope can be a real impact. So lamprey can potentially not keep up with that water as it's being removed. It can also remove water from a large area. So you need to be out there and tracking those really shallow environments that might have a lot of lamprey. Temperature and solar radiation can play an impact on whether or not lamprey are surviving these dewatering events. The larval size, the depth of burrowing. We think larger larvae tend to burrow deeper than smaller larvae, so they might take longer to reach the point where they want to come out or feel that they need to come out. So a lot of different factors involved in whether or not lamprey are coming out, and based on a number of lab studies and a couple of field studies, we think roughly about 50% of them emerge after that water is removed. And so we recommend using lamprey-specific electrofishing to encourage more lamprey out so we can salvage them. So traditional cell-mounted settings that we use when we're doing, where we're moving fish from a project site are going to trap larval lamprey in the sediment. So the way that they experience those electrofishing settings, they're not going to be able to swim against it, and they'll be trapped in place. And so we recommend using electrofishing settings that are specific for larval lamprey. And the big difference for those settings is they're really low voltage. We don't want to immobilize the larval lamprey. We want actually them to be able to move. And so it's a really low voltage. And then it's also a pulsed settings. So it's 3 pulses per second with 1 pulse off. There's a little picture here of the way that the waveform is designed for our primary waveform. And the reason it's pulsed is, again, we just want to, we call it a tickle setting or an annoy setting. We want them to get out. So if they're staying in the sediment, they might be harmed, they might be trampled by equipment, they might be excavated and put on the side of the stream. We want to get them out. And so the low voltage and the pulse is really just to try to get them to encourage them to swim out of their burrows. So it's a really low impact electrofishing. They will still be able to swim. They will come up and start swimming away. And so you'll have to net them actively. We also have a secondary waveform that can be utilized, which is very similar and can be set up the exact same as your traditional sun-mounted settings. And that is our stun setting. So if the lamprey are emerged and are swimming away, you can stun them and they will stop swimming. So it'll be, again, much similar to the way that we are sampling for other fish. But the caveat being, as I mentioned before, that lamprey don't have a swim bladder. So they will sink once they stop swimming. And so that is, as the netter, you got to remember that they're going to be sinking. So this can be particularly useful if you're in a little bit deeper water and you have time to scoop under them. But if you're in pretty shallow water and there's lots of sticks and leaves, it can be not that effective because they'll just kind of sink in there. Might be hard to scoop up. So I personally use tickle almost exclusively. I almost never use the other waveform. But it can be an additional tool in the toolbox. Smith Root has an excellent video and like step-by-step instructions for setting up your backpack electrofisher for the lamprey settings. And I would recommend doing this ahead of going in the field because it does take a little while. It's a many-step process. But you can set up the primary waveform, that tickle waveform, and then the secondary waveform such that if you push down once on the toggle on the electrofishing backpack, you'll start the primary waveform. And if you push down twice within a second, you'll start the secondary waveform. And the beeping will change so you'll know you're switching back and forth. And I recommend just saving that setting as your like 10th save setting. So you can just go and know that it's saved, know that it's there when you get in the field. I always have my salmon setting as number 1 and my lamprey setting as number 2, and then you can toggle back and forth. Again, depending on the scale of your project, when it comes to salvage, you might actually have just one fish crew. They're going out and they're going to salvage all the species. And so you can be shocking in one area using your salmonid settings, collecting your bony fish. Then you come into really awesome larval lampreys habitat, and you'll just switch over. One of the netters will just toggle over to your lamprey settings. You can shock there for your lamprey, collect those, and then move on. Or if it's a larger project, what we've done is we have 2 crews. We have a bony fish crew and we have a lamprey crew. So we'll have our bony fish crew go first, give it around 15 minutes to let the fish recover from that initial pass. And then we'll send our lamprey crew through and they'll target slightly different habitats, but be using those lamprey settings. So varies again, depending on the size and scale of your project. But the Smith Root backpack electrofishers are very easily adapted to lamprey settings. And again, you'll learn how you prefer to use the waveforms, but the nice thing about the tickle setting is it is ideally having a much lower impact on the other fish in the stream because again, it's that low voltage and it's pulsed. So it is annoying them, they'll swim away, but they are not going to be immobilized, and they will just kind of move from the area that you're shocking your lamprey.
Knowledge check. True or false? Which of these are true and which of these are false? 1. Arguably the most important piece of lamprey salvage equipment are fine mesh nets, because larval and juvenile lamprey are so small they can slip through large gauge nets. 2. It is a good idea to leave a bucket, fine mesh net, and aerator behind in case lamprey continue to emerge after dewatering is done. 3. After an area is dewatered for 6 consecutive hours, any individual lamprey remaining in the sediment will not survive. And 4. Typically, lamprey-specific electrofishing would be implemented after the channel has been swept to encourage fish out of the work area, block nets have been set up, and the fish rescue team has completed seining and e-fishing targeting pelagic fishes, including salmonoids. However, lamprey-specific electrofishing can also be conducted concurrently to traditional salmonoid-targeted electrofishing. Answers 1, 2, and 4 are all true. Answer 3 is false, because lamprey have been observed to be alive for up to 22 days after surface water removal. Survivability of a dewatering depends on site conditions.
So this is an example of what we call dry electrofishing, and this can also be a really nice tool to utilize for your salvage projects, because we will have removed the bony fish from the area, and then we'll have these wetted sediments that remain once we start our dewatering. And this can be where we have really high densities of larval lamprey. They do not want to come out. So we can use that same pulse setting, this is that tickle setting. And so we've got our probes around 1 meter or so apart, just setting on the surface, and it's sending that pulse wave through there. And you can see all of these little larval lamprey coming out of there. So not done with salvage. Play it one more time. Because you can see over here too where you can see kind of the edge of the impacts of the electrofishing, but there's so many larval lamprey in there. So this is just another great tool that, again, is not going to impact any of our bony fish, especially if it's ESA listed fish at the site. And we can use it to get a lot more lamprey out of our dewatering areas. So basically, in order to incorporate lamprey, we just have a couple extra steps in our dewatering process. If possible, it is really helpful to conduct a pre-drawdown lamprey survey to see presence and absence, really get a feel for what your densities are, so you can plan ahead. That's not always possible, but if possible, that can be helpful to inform your plan. It's also a great time to do your initial mussel relocation. Freshwater mussels are at many of our sites, and we don't always know that they're there. And so if we can do a pre-project assessment and plan if we're going to have mussels at site, that can be a good time to do that. When you perform your initial passes for your bony fish, we basically suggest kind of swapping back and forth between bony fish and lamprey, so that you're conducting those multiple passes for both groups of fish. And removing them before the project gets rolling. And then as you perform your drawdown, removing all species, paying attention to any parts of the project that are being fully dewatered. So there's exposed sediment, you might see a lot of lamprey there. And then performing dry electrofishing on those exposed sediments where there's a lot of larval lamprey, or where you think there might be some. The dry electrofishing is also a nice addition to the salvage plan, because oftentimes mussels are coming up after the water is removed as well. They tend to kind of hunker down. They're also trying to wait it out, but then once that water is removed, they start to emerge. And so if you're doing those later passes to collect lamprey, you can also then be collecting freshwater mussels during that time. So in theory, the idea behind just kind of getting this information out about lamprey settings is that it allows us to plan ahead of time. And we're not kind of scrambling. I have been at project sites. That's one of the reasons why I became interested in lamprey, is because we were dewatering a project site, and there were just tons of lamprey that started emerging from the sediment, and we were completely unprepared and had to stop everything, have the construction crew come in, help collect lamprey, and it delayed the project. And so if we had planned ahead of time, we could have, planned more efficiently to use our time, potentially started our de-fishing earlier, not had the construction crew waiting to get going on excavation, because they might need, we might have need more time on fish salvage. And so ideally we're saving kind of that stress and struggle and wasted time and money by planning ahead of time. But it does, to incorporate lamprey, it often takes a few extra steps. And sometimes that's only a matter of a few minutes, especially if it's a small project, small footprint, just salvaging lamprey using those lamprey settings. In other cases, it can take a lot longer. So planning ahead can be really beneficial. So in kind of summary, as far as in-water work processes, we're just really trying to think about lamprey at every step of that planning process. So that's from the pre-project assessment. Are there lamprey present? Is there habitat present? what is the current use of lamprey at that site, and are there elements we want to save and conserve? Or are there things that we really want to enhance because we know there's no larval habitat at this site? We don't think there are many lamprey because it's this really embedded and large substrate, no fine sediments, no structure. We're going to go in there and make it way better for lamprey. But it's good to know that ahead of time so we can kind of plan and incorporate those elements and also think about salvage. As far as design elements, a lot of what we're doing for salmon is going to be benefiting lamprey. But specifically for lamprey, we want that complexity and connectivity between those environments because they're going to be using so many different substrate types and so many different habitats over the course of their life history. So encouraging lateral and vertical connectivity, adding structure to increase that sediment sorting, increasing wetted areas, really beneficial. And then also, very importantly, those longitudinal connectivity of migration corridors. And that is particularly important for our naturalist lampreys that are going all the way to the ocean, but also important for our resident lamprey. They're going to be needing those different environments at a kind of more localized level. And then during implementation, being prepared to have potentially a lot of lamprey at your site and planning ahead of time to reduce those impacts and hopefully salvage more lamprey. The Pacific Lamprey Conservation Initiative has a website, pacificlamprey.org, and there are tons of resources available on this website. So the goal of the initiative is to produce white papers and best managed guidelines and any information that we think practitioners and biologists can use to protect lamprey. So there is an in-water work best management guidelines, best managed or barriers assessment for road crossings. There's a fishway guide, there's a habitat restoration guide, and this restoration guide is hopefully going to be updated in the next year or so as well with new science because lamprey science is ever evolving. But there's tons of great resources. And these resources are produced by the technical work group. That's part of the Pacific Lamprey Conservation Initiative, and then it's subsequent subgroups. So these are a list of the subgroups that are actively trying to advance science when it comes to lamprey. So there's a really cool genetics group. There's a ton of really neat genetics happening in the lamprey world. So it's focused on DNA and eDNA advancements. There's a juvenile treatment, dredging, and dewatering investigations, or the JEDI group. And so they're the ones that are looking into a lot of the dewatering, obviously in the name, dewatering impacts, how lamprey are emerging and being burrowed. There's an adult passage group, and that one we're hoping to get a truck and haul paper out in the near future for making recommendations on that. So really cool nexus for keeping up to date on the science of lamprey and then also producing recommendations for managers. So if you're interested in participating in this group, it's open to anyone, and it is just a great group of just people trying to stay up to date on lamprey science. We also have the regional management units, and so these are based on geographic range because we don't have, again, the distinct population segments or evolutionary significant units that kind of dictate our management of salmoniid species. But we have these regional management units, and they are made up of local biologists and managers that really know the threats that exist on the landscape. They know the populations of fish. And so we meet on an annual basis to kind of share about projects that are going on, share science, get information out to folks, but then also there is funding available through a couple of different entities specifically for lamprey. And so these are really also a cool way to stay engaged in what's happening in your local region. So if you're interested in joining the Pacific Lamprey Puget Sound Strait of Wanapeka Regional Management Unit, let me know because I am the lead of it and I'll get you on the list. Another great resource is, and many of you are probably familiar with this, but Xerces cited the mussel friendly restoration. And they have a really awesome just kind of walkthrough of how to plan for and implement mussel salvage at restoration projects. They are a wealth of resources when it comes to mussel information, and potentially the Western Virtual mussel is going to be, it's currently being petitioned for listing under ESA. So this will also be more of a consideration in the future with that potential listing. So that,
Do we want to pause for?
Yep.
For some questions? We've got a bunch of questions
Great.
about these recent slides. So, Joelle asks about meander bars and if they provide that larger back eddy structure that lamprey need to pass through the pool. And these are going to be properly sized
Yeah.
culvert after
The-
correction
yeah.
of the stream
Yep.
continuation.
yeah, totally. So, I would say yes. I think any area that's gonna have like a low velocity, kind of resting area and then allows them to get into the higher velocity areas would be beneficial. So I would say, yes, having just flow path diversity and having those areas where there's areas where lamprey can rest is gonna be beneficial. Is that what that meander bar downstream or upstream?
Sometimes they're in the structure.
Oh, I see. Yes. You're like building that as part of your, so you have a curve through your structure. Totally great. Again, flow path diversity. So you're gonna have some flow pockets. I think that would be probably beneficial. I think in addition to that, adding some of those larger substrates, would be nice. So, and sometimes that is part of that, right? Because we're using those larger substrates to create that meander. So I think that would be great.
Are lamprey considerations part of why we've seen a recent decrease in the net screen opening size for HPAs, dictated from WDFW?
Potentially. So depending on the thing with HPAs is that, depending on the biologist that is reviewing them and issuing them, some of them have been adding lamprey provisions for a long time. And then others, if they're not aware that there needs to be lamprey provisions. Again, lack of awareness is one of the big hurdles to lamprey conservation, and that's on every level. That's from the first graders that learn about salmon for like forever in the public schools, but never learn about the lamprey life cycle, to biologists, and managers who we just don't know about lamprey until all of a sudden you choose to find that information. Is really what it comes down to. So for HPAs, definitely, I think if there's smaller screening regulations being implemented or provisions being added to those, it's potentially for lamprey. It can also be for Ulicon, depending on the location, our local smelt here, because there's a number of smelt species that we want to conserve, and they're also smaller bodied fish. And so it wouldn't just be lamprey, but it could be that that's a contributing factor, for some of those provisions.
Do we think that, US Fish and Wildlife Service or NIMS will be regulating lamprey if or when they are listed? And do we know anything about if or when they may be ESA listed?
So the goal of the conservation initiative is to avoid listing. There is more genetic information than there was 20 years ago when the initial petition was proposed, which again kind of suggests there might be these regional, very kind of broad genetic differences. Not in the same way that we see with salmon and steelhead. It's not those really distinct delineations. But there may be more of a case to list, like a Columbia basin, a larger, part, but a smaller part of the population. But the goal of the initiative is to avoid that. We want to implement enough conservation effort that we are recovering the species without having to do that. And I think there's a lot of appetite within the initiative to do that. And I think we are moving that dial as far as getting more and more people to incorporate lamprey just as part of projects. So for example, in Oregon, the Oregon Water Enhancement Board, which is kind of like the surf board equivalent, they now have questions in every grant application. How is this project serving Pacific lamprey? Like, what are you doing to incorporate them? And so I think that there is more and more a move to just have lamprey be a part of our planning and implementation broad process. That being said, that varies greatly over their range. And we don't have data in most cases to say if anything that we're doing is impacting the population yet. I think in the next several years, we're gonna get more information. We have areas where we have a little bit longer data sets, like we will hopefully see more of kind of how that's impacting the population as a whole. But because they're so mixed, because they don't necessarily return their basin, like we need to be doing these efforts, you know, at the global scale for Pacific Lamprey in order to impact them. And so I think that there currently is a feeling that the work that's being done is moving them in the right direction. And ESA listing does not necessarily equate to progress. So for example, Ulicon, smelt are listed under the Endangered Species Act, and they hardly get any funding. My supervisor and the rest of my team work on Ulicon, and they are struggling to get support and funding to focus on that fish, even if they're ESA listed. And so just because lamprey would be listed wouldn't necessarily facilitate a ton more effort being put into them. And we currently have 2 funding sources and a lot of people working on conservation. And so, so sometimes ESA feels like almost a silver bullet because salmon gets so much funding and they get so much attention. But that's also because salmon are culturally extremely important, commercially extremely important. Like there's so many reasons why we focus on them. Whereas if a fish does not fall into that kind of really, really important category, they still may not get as much conservation. But that is where, when we think about screening, when we're thinking about some of the passage, you know, I think that we have a lot of improvement that can be made on the passage front and incorporating lamprey into passage. If we start doing that now, then again, we are either prepared if listing comes, or we can avoid that altogether. But it is a conversation, you know, that comes up, and not to say that it won't happen, but there's hope that we can move enough and really engage people enough that we're going to be implementing those methods that we would use for conservation under ESA without having to have ESA.
The next question I can give us somewhat of an answer to. So Joelle asks if WashDOT will be updating our fish exclusion protocols to include several of the lamprey exclusion methods that Monica touched on today. We had a little bit of a discussion earlier this week and talked about how fish exclusion removal is currently covered by HPAs, and lamprey is included in that. And so Eric Gower looked up a quote of some HPA permit language, which goes, the permittee or authorized personnel must capture and safely move food fish, game fish, and other fish life from the job site. And there's certainly more of a conversation to be had because there's much more information about lamprey and more salvage methods. And so I think that should be discussed. So more to come.
I agree. Yeah, and I think that that's one thing where some of the habitat biologists for WDFW are writing specific provisions for lamprey, because when we give these generalized fish exclusion, like people remove fish, like most people think bony fish, you know, and so they that is like just what comes to mind, and it does not necessarily explicitly say like you have to do extra steps.
Yeah, I asked that too, because like for our fish excluding protocols, we kind of have like, you know, you need to do 3 passes with no fish to be considered sufficient. And so I guess kind of what I'm getting at with my question is like, are we gonna have guidelines that kind of dictate like what sufficient exclusion will be for lamprey as we kind of move forward with that? So sounds like more to come.
It's a good question. There's a lot of strategies here that I think should be considered.
Yeah, because yeah, like you said, they can kind of keep coming out of the ground for
Yes.
like a long time. So it's kind of like when can we get to a point that we're comfortable with like how we've excluded our sites? So,
Yeah, and I think that'd be an awesome conversation to have, just because, so there's an example that I always tell people about. We did this, it was huge fish salvage on this creek down in Southwest Washington. It's called Steiger Wildlife Refuge in Skippers Creek. And it was like, I can't remember if it was a kilometer and a half. It was essentially a ditch full of vine sediment. It was just chock full of lamprey. So we did 4 days, 30 people out there every day, full days of salvage. We got 40,000 lamprey.
What?
And we didn't see depletion. Like, they just kept coming. And so I think that there's a reality, right? You cannot keep going. You cannot have 30 people out there for the next 2 weeks to see that you've gotten all the lamprey. And so I think that potentially, something to think about is like, if you're doing a number of passes for bunnyfish, you do those same number of passes for lamprey, or you're doing them in tandem. Because again, it really does depend on the scale of the project. In some cases, it's really easy to switch back and forth. If you're on a small creek and you can just be sampling larval habitat over here, bony fish, as you're walking down the stream, and you can basically do them at the same time, in which case you don't have to add extra steps or extra passes. But in other cases, it really is easier to just do your bony fish and follow with the lamprey pass. But in other cases, it might be that you don't do much lamprey salvage ahead of time, and you do it all after it's dewatered. And then you do a dry electrofishing, and you do as much as you can for a certain amount of time, and then you call it good. So I think there's different ways to address that kind of stop point, because we do have to have a stop point. And that can be just really different depending on the project site. But it is a really good point and a really good conversation to have of how do we actually put this in writing so that it is doable. The other hard thing is like WashDOT is a large agency that like has staff and has contractors, and we can work on this outreach and we have equipment. There's also projects where it's like individual landowners, and that might be a completely different outcome, because that is a group of people that don't have as much support to conduct these. And so we've been talking at the HPA level of like, for certain size projects, what we are recommending for salvage might be literally letting the water go out, wait an hour, pick up as many lamprey that are there, and then start your work, because you might not have the ability to let your fish to salvage methods in a more effective way. But we as the agency have a little bit more of that power potentially. So we can really like have a little bit more of a regimented and prescribed salvage plan. Great question.
Thank you, Joelle.
Yeah,
Super
super
great
good.
question. Okay, we've got one more question for this section. Before shocking, while setting up fish exclusion, we often try to scare fish out of the work area. So maybe taking a seine net and just doing sweeps or smacking a yoga ball to make noise. Is there anything you can do before shocking to encourage lamprey to get out of that area?
Yeah, good question. So I think that potentially some of those methods might potentially work for the adults. If there's adults holding, and there's a lot of commotion, they might exit. They also might just like hunker down and hold, especially if they've got a pretty cozy spot, if they're like in really like riprap, there's big interstitial spaces. So if you've got riprap at a project, a lot of times you're actively removing, they can be burrowed in there. So I think to some degree, the adults might be responsive to that. I think that those methods, seining, minnow traps, a lot of stuff we do pre-project, if we're potentially not using electrofishing or trying to avoid, electrofishing as much, those are not going to be super effective for lamprey. So you might get occasionally, like when you're walking and stuff, you might scare a few lamprey, but they'll usually just go like right back in a different location. And so probably not. But if there is a reason that you are not using electricity, like you're planning on seining, and that is our method for defishing. And then when you're starting to draw down the water, you're just dip netting and scooping up fish. The dry electrofishing can be a tool after the fact when you have removed all your bony fish, and then really just targeting those areas where you see a lot of larval lamprey coming up and you want to get more of them out of that sediment. So I think that that is what I would recommend for if there's a reason that we're not using electricity at one of these sites, which I know is becoming, depending on the site, depending on the EFA listed fish, that is really like, we're trying to not use that. So the benefit of dry ledge fishing is you are looking at the sediment and it is dry and there are no bony fish there. The other thing I was gonna say, just referencing the adults and the riprap, for remove, so lamprey just, again, some of them are just gonna hunker down and stay there. But when you're, so you might have areas that like there's still like a wetted pocket in that riprap or, and they'll just hold there. So what we kind of recommend is when you're removing that riprap, just have someone watching to see if a lamprey is trying to get out of there. So if there's still some water in there, they'll try to swim out, watch them, they'll get swimming in the mud. So that's just another idea to keep in your mind, that the adults can also be on the site after the fact. So keeping that net and bucket on site, and having someone that is just paying attention. A lot of times you've got a project manager on site the whole time, and so they can be kind of tasked with just looking and making sure that if there's lamprey coming out, they can be picking them up. It's hard to miss a giant Chinook salmon in these sites. We're also avoiding times that they're there, but it's crazy that we can have these adult lamprey that are just at the sites, and we just, they are commonly sitting right below those culverts we're pulling out because they can't get over. There's riprap, so just having someone that is watching as that riprap is being removed, because oftentimes that's the point where lamprey are trying to get out. Okay, so just in summary, those are awesome questions, and I really think that this is a complicated issue of trying to salvage lamprey because they just act so differently than our bony fish. But I think that it is just the fact that we now, in many cases, are talking about it and thinking about it. There are a lot of methods that we can employ, and it's just a matter of how do we fit them in, how do we delineate them so that people understand what's expected too, because that is important to make sure that we know what we're asking people to do. The exciting thing with lamprey is that our scientific understanding is ever evolving. I've been in this position for only 3.5 years, and the amount of things that have changed and updates that we have and new science that's out there is so much. And so that is a really exciting thing with lamprey. And honestly, almost every observation in that we are making, when we see lamprey, that can be like an actual new documented lamprey habitat, because we just have so little data, and especially in the Puget Sound area. So for those of you who are out in the field and interacting with these fish, it's really exciting because those could be areas where we didn't even know they were until you went out there and did a project. So feel free to reach out anytime to ask me questions, because this is, as I said, ever evolving, and we might have new recommendations for the next 6 months. And so if you've got project sites that you are curious if there's lamprey there or how to incorporate lamprey, every project site's different, and more than happy to collaborate and talk about how we can incorporate them into those sites. Generally speaking, I think a lot of the work that we're doing is really benefiting lamprey. The work that we are doing across landscape, mostly in the name of sunwaters, but also just kind of general restoration. I think we are going to see some benefits from that, but there are some explicit considerations for passage, for restoration, incorporating those year-round wetted substrates is going to be really important for enhancing lamprey into the future. And then just the fact that we do not have an in-water work window that avoids them. So really thinking about how to salvage them at those locations.